Alright, so this is a neutralization question from the textbook, page 398, number 10. Quick note, anytime there's a neutralization reaction, it's a type of double displacement. So your positive ion from the first reactant is going to switch with the positive ion from the second. So you're going to end up with NaNO3, and then of course you'll end up with what looks like HOH, but you have to remember that that is water, and that's what gives the final solution its neutral properties, because you're making water. The properties of the acid and the base are canceling out with one another. Now, in this question, it reads that there's 17.85 milliliters of nitric acid neutralizes 25 milliliters of 0.150 mole per liter sodium hydroxide. What is the concentration of the acid? So we haven't done any stoichiometry with solutions yet, but it's not using mass and molar mass, it's using molarity, volume, and moles. Now, you have to remember, if you're looking at molarity, it's in moles per liter. So in this question, they give you the molarity of the NaOH, which is 0.150 moles per liter. They then give you volumes in milliliters. You need to convert those to liters in order to make sure everything's compatible. So it tells you it neutralizes 25 mils, which is 0.025 liters of NaOH, and it only took 0.01785 liters of the HNO3. And here's what we're looking for. Now, the process here is going to be to figure out how many moles of the NaOH has been neutralized. Assume that when things are neutral, you would have the equivalent number of moles of HNO3, and then work your way up to molarity. Here's where these stoichiometry problems with solutions get a little bit tricky. We're used to just dividing, but remember, back to our molarity equation, molarity equals moles over volume. If we want N, it's actually going to be the molarity times the volume. So we need to multiply these things down this column. So with NaOH, it's going to be 0.15 times 0.025, and we get 0.00375, or 3.75 times 10 to the minus 3. Now again, when this thing is neutral, recall, you have to have equal amounts of the acid and base. It can't be a limiting reagent problem, because if you add more acid than you needed, then the final solution would be acidic. So the idea here is that you're adding perfect amounts of acid to base, so they completely neutralize. So here's the idea. At neutralization, or when, let's call it at neutralization. I think technically we'll introduce the equivalence point tomorrow. The moles of your acid has to equal the moles of your base. So the 0.00375 goes up here. Now we're working our way back up a column. Remember, it's not multiplication anymore, because we're looking for molarity. You're actually going to take our number of moles and divide by the number of liters, and this would give us our concentration. So I still have the number of moles in the calculator. I'm going to divide by 0.01785, and I get 0.210 moles per liter. Now, I did show in the slides that there's a hack you can use here, but it's only for monoprotic acids. In other words, 1-to-1 ratio acid to base. The moment you start getting 2-to-1 ratios, this hack breaks down. So the hack relies upon this idea of the moles of hydrogen equaling the moles of hydroxide. I expand in the PowerPoint this idea. If you wanted moles, remember, going back up to this equation, it's molarity times volume. So if you take the molarity of your acid times the volume of your acid and set that equal to the molarity of the base times the volume of the base, you can actually solve for whatever you wanted. In this case, we wanted the molarity of the acid. So we had the volume of the acid, we had the volume of the base, and we had the molarity of the base. If we plug those three things into this equation right off the hop, we'll end up solving for the molarity of the acid. So I know it was 0.0175 liters, 85 liters. I'm looking for the molarity of the acid. I know the molarity of my base is 0.150 moles per liter. and the volume of the base is 0.025 liters. So molarity of the acid is going to be equal, bring this over as division, 0.150 moles per liter times 0.025 liters, all divided by 0.01785 liters. And this is exactly what we did up in the table, but you're there essentially in one step. So 0.150 moles per liter times 0.25, which is what we did here. And then we brought it over here and divided by the liters. It's going to give us the exact same concentration. You can try and see if you get anything different, but take my word for it. It's going to give you the same concentration. So we end up there using the hack method, which is kind of with a, an ad-lib formula. It makes your life quicker. But remember, has to be a 1-to-1 ratio. The moment your original equation needs to be balanced, you got to throw this process out the window, and then you got to go back to columns.